गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक चैप्टर सॉलिड से है टाइप्स ऑफ क्यूबिक क्रिस्टल्स एंड नंबर ऑफ एटम्स पर यूनिट सेल। नंबर ऑफ एटम्स किसी भी यूनिट सेल के कैलकुलेट करने से पहले ये ऑब्जर्व करना बहुत ज़रूरी है कि एटम्स क्या यूनिट सेल को बिलोंग करते हैं अकेले को कि शेयर भी हो रहे होते हैं। तो यहाँ आप देखेंगे इस डायग्राम में ये जो कॉर्नर वाला एटम होता है ये जिस यूनिट सेल का पार्ट है उसके साथ साथ 8 और यूनिट सेल्स से शेयर हो रहा होता है। 4 लोअर लेयर में है और 4 अपर लेयर में है। तो इस तरह से अगर एक एटम 8 यूनिट सेल्स का हिस्सा है तो दैट मीन्स उस एटम का सिर्फ 1/8 पार्ट उस यूनिट सेल का पार्ट है। सो वन एटम belongs to or is being shared by 8 unit cells, and the contribution of that atom to its own unit cell is only 1/8. Then similarly, the atom present in the center of any face, for example in this unit cell, atom is present in the center of this face is being shared by the adjacent unit cell as well. So if one atom is a part of 2 unit cells, then its contribution to one unit cell is 1/2. So an atom present in the center of face, its contribution to unit cell is 1/2. Thirdly, the atom which is present in the center of the body of the unit cell is being shared by none other unit cell. So its contribution is completely to that unit cell. Its contribution is full 1. And the atom at the corner contribution is 1/8. A face-centered atom has contribution 1/2. And a body-centered atom has contribution 1. Now let us begin by finding out the number of atoms in a simple unit cell, that is a primitive unit cell. In a primitive unit cell, these are the different ways of representing a simple unit cell. Here, this is an open structure where we show the unit cell and the atoms smaller in size. Actually, these atoms are touching each other, but in the open structure, just to show the edges and the placement of atoms, they have been shown far apart to each other. This is the actual space filling structure where you can see that the atoms are actually touching each other. And this diagram has been made with respect to the contribution of each atom present in the unit cell. So as you know that the atom at the corner, its contribution is only 1/8 to that unit cell. So only 1/8 of the atom is shown here. So number of atoms in simple or primitive unit cell will be, we find out first how many atoms are present at the corners. So there are 8 atoms at the corners in the unit cell. The contribution of each atom is 1/8. So 8 into 1/8 becomes 1. So number of atoms in a primitive unit cell are only 1 atom per unit cell. Next is a face-centered cubic unit cell. So this is the open space structure where you see that atoms are present at the 8 corners and also in the center of each of the 6 face. So this is the diagram where we see the atoms with respect to the contribution they are making to the unit cell. So you can see that the atoms present at the corner, they are giving only 1/8 of the contribution to the unit cell. So total 8 into 1/8 will make the number of atoms in this unit cell at the corners equal to 8 into 1/8 is equal to 1. Similarly, the atom which is present in the center of the face is being shared by 2 unit cells. So half of this atom is being shown here. So there are 6 face. So that means 6 atoms at the face will be multiplied by their contribution to the unit cell, that is 1/2. 6 into 1/2 makes 3. So how many atoms do we have in a face-centered cubic unit cell? 8 into 1/8 is equal to 1 and 6 into 1/2 is equal to 3. 1 plus 3 So total number of atoms in a face-centered cubic unit cell is 4. Next is body-centered cubic unit cell. A body-centered cubic unit cell, its open structure shows that atoms are present at the corners and in the center of the body. And the contribution is 1/8 of each atom present at the corner and one full atom within the center of the body. So total number of atoms in a body-centered cubic unit cell will be 8 into 1/8 at the corners and 1 in the center. So 1 plus 2, 2 atoms are present in a body-centered cubic arrangement.